Hello students, in this video we will study classification of substances on the basis of their magnetic properties and their behavior in the presence of magnetic field. We know that there are large number of elements and compounds on earth. So all substances are classified on the basis of their magnetic properties. So let us start. In classification of magnetic materials, the first is diamagnetic substances. Those substances, when placed in external magnetic field, are weakly magnetized in direction opposite to the magnetizing field are called as diamagnetic substances. That is, they are magnetized in opposite direction. They also repel when brought close to the pole of a magnet. Such substances are termed as diamagnetic substances. The second one is paramagnetic substance. These are those substances which are weakly or feebly magnetized in the direction of the magnetizing field. And the third one is ferromagnetic substance. These are those substances which are strongly magnetized in the direction of the magnetizing field. That means this shows strong magnetization, this shows weak magnetization, and this do not magnetize at all. So, how can we classify these substances? If a substance has magnetic moment, then it is a magnetic substance. If magnetic moment exists, it is a magnetic substance. If there is no magnetic moment, then that substance is not a magnetic material. So, the behavior of diamagnetic, paramagnetic and ferromagnetic substances can be understood by the atomic model also. We know that matter is made up of atoms, and each atom has positively charged nucleus at its center, around which electrons revolve in discrete orbits. Now, we know from our previous video of magnetic dipole moment of an atom due to revolving electron that each revolving electron is equivalent to a tiny current loop or magnetic dipole. So, Ampere suggested that the magnetic properties of the material are due to these tiny loops within the material. Also, these tiny loops are due to the motion of the electrons. What does it mean? We have studied in our previous video that when current flows in these tiny loops within the atom, then each current loop has magnetic moment associated with it. It has two types of magnetic moment, that is the orbital motion of the electron, which leads to orbital magnetic moment, and also when the electron spins or rotates about its own axis, then we have a spin magnetic moment. So, the internal magnetic field in the material is produced by electron orbiting around the nucleus, that is the orbital magnetic moment, and the spinning of the electrons, that is the spin magnetic moment. So, the vector sum of both magnetic moments will actually decide the internal magnetism produced in the material, like this: the orbital motion and the spinning of electron about its own axis. Now, by these vector sum or the total magnetic moment, we will be able to decide the three kinds of the classification, that is diamagnetism, paramagnetism and ferromagnetism. Diamagnetism is found in those substances which have even number of electrons, remember this, even number of electrons, and they form pairs. In this pair, the direction of spin of one electron is opposite to the direction of the spin of other electron. So, the net magnetic moment of one electron is neutralized by the other. Hence, the magnetic dipole moment of diamagnetic materials is 0. When such substances are placed in external magnetic field, the field changes the motion of the electrons. One electron in each spinning pair is slowed down, while the electron in the other spinning direction is accelerated. Alright, that means if there are two electrons in a pair, one is accelerated and one is slowed down. Therefore, they both are not able to neutralize the magnetic moments of each other in diamagnetism. Thus, a small magnetic moment is induced. I am using the word induced. Small magnetic moment is induced in each atom, which is proportional to the magnetic field, but its direction will be opposite to the direction of the external magnetic field. Hence, such substances are magnetized opposite to the external magnetic field. Now let us understand for paramagnetism. It will be easy for us to understand their properties then. So what in paramagnetism, it is found that the atoms have an excess number of electron spinning. Therefore, the net magnetic moment is non-zero. It has non-zero magnetic moment. Alright, and behave like tiny bar magnets. But in the absence of external magnetic field, they do not have any magnetic effects. Actually, what happens that all the dipoles are randomly oriented like this. They have tiny magnets or dipoles and all are randomly oriented like this. So the average magnetic moment is 0, but when external field is applied, now external field is applied, it tries to align the dipole like this. That means all in the direction of the external magnetic field, and the material gets magnetized weakly in the direction of the field. I am using the word weakly because these are paramagnetic substances. They get weakly magnetized in external magnetic field. Ferromagnetic substances. Now let us understand for ferromagnetic substances. Here also each atom is a tiny dipole having permanent dipole moment or non-zero dipole moment. Only difference from paramagnetic here in ferromagnetism is its intensity. That means how deeply it is magnetized. That is, they acquire strong magnetism in external magnetic field. Here we have said weak magnetism, and here I am using the term strongly magnetized in the presence of external magnetic field. Here, due to mutual interaction between the atoms, they form a very large number of small regions called domains. That means small regions are formed, and each domain has very large number of atoms, about 10 raised to the power 10 atoms in each domain, and these atoms have their magnetic axis aligned in the same direction, but their direction is different from the neighboring domain. Likewise, this, suppose there are a number of domains, I am representing only 4. The magnetic moments, the directions are aligned opposite to the direction of the neighboring domain. Therefore, each domain is in magnetic saturation, or each domain is a strong magnet. But in the normal state, when we combine all the domains, they are randomly distributed. So therefore, their resultant moment is non-zero. But as soon as the magnetic field is applied, these domains try to align according to the external magnetic field. Likewise, suppose the external magnetic field is in this direction. So the favorable domain, this is the favorable domain, this domain will try to increase its size or will rotate until their magnetic moments are aligned in the direction of the magnetic field. Likewise, that this domain will increase like this, that this domain is increased, and rest all the domains are trying to align according to this favorable domain, because it is in the same direction as the external magnetic field. So it will lead to this. That means all the domains are now aligned according to the same direction as the external magnetic field. So now this material is magnetized in the same direction as the external field. But if the magnetization or the external magnetic field is removed, its magnetization disappears. So in materials like soft iron, which are termed as soft ferromagnetic materials, and like alnico, the magnetization persists after the removal of the external magnetic field also. Such substances are termed as hard ferromagnets. Now let us discuss its properties based on this understanding. So let us start with diamagnetic substance. These are those substances when placed in magnetic field acquire feeble magnetism, that is weak magnetism in a direction opposite to the direction of the magnetic field. Likewise, suppose this is the magnetic field direction and this is the substance which is diamagnetic, we have placed in magnetic field. This is the direction of the external magnetic field, so this will be the north pole and the south pole. It will acquire feeble magnetism in a direction opposite to the direction of the external field. And when we place paramagnetic substance in magnetic field, it will acquire feeble magnetism in the same direction as the magnetic field direction, like this. And just I have told you that the difference in ferromagnetic and paramagnetic substance is their intensity. So when such substance is placed in magnetic field, it will strongly magnetized in the direction of the magnetic field. These substances, diamagnetic substances, are repelled by the magnet, and paramagnetic substances are weakly attracted by the magnet, while ferromagnetic substances are strongly attracted by the magnet. Just I have told you that the electrons in diamagnetic substances are even in number and they will neutralize the effect of each other, hence the resultant magnetic moment of diamagnetic substances 0. In paramagnetic substances, the magnetic moment is non-zero. Also in ferromagnetic substances, the magnetic moment is non-zero. In diamagnetic substances, now if a diamagnetic solution is formed, and if we pour it in a U-tube, its one arm is placed between the poles of a strong magnet, the level of solution in that arm will be lowered. You can understand it like this, that if there is a U-tube, we can draw the U-tube like this, and we fill it with diamagnetic liquid inside the U-tube, and in the one arm we have placed the poles of a strong magnet like this. Then, as the property of the diamagnetic material is that it will repel the poles of the magnet, so the level of the solution in that arm will be lowered as it is repelling. But in paramagnetic material, when its solution is formed and poured in a U-tube, its one arm is again placed between the poles of the strong magnet, the level of solution in that arm will increase. See again, this is the U-tube, and these are the poles of the strong magnet. This is the paramagnetic solution. Here the property of the paramagnetic substance is that it is going to feebly attract, so the level of the solution in the U-tube will rise. Same is the case, but ferromagnetic substance also experience the force in magnetic field, but we rarely found any ferromagnetic substance in liquid form. If a rod of diamagnetic material is suspended freely between the magnetic poles, its axis will become perpendicular to the magnetic field. You can understand it like this. These are the poles of the magnet. The magnetic axis will be perpendicular to the magnetic field if it is a diamagnetic material. And if it is a paramagnetic material and we suspend the material freely between the poles, the axis becomes parallel to the magnetic field like this. Same is the case with ferromagnetic material. Its axis will also become parallel to the magnetic field. The permeability of diamagnetic substance is less than 1. They have least tendency to pull in the magnetic field lines when placed in external magnetic field, while the permeability is slightly greater than 1 for paramagnetic substances, and it is much greater than 1 for ferromagnetic substances. It tells us about the tendency to pull in the magnetic field lines when placed in an external magnetic field. The susceptibility is a small and negative value, and it is independent of temperature in diamagnetic substances. While in paramagnetic substances, the susceptibility is small positive value and is inversely proportional to the absolute temperature of the substance, which is also known as Curie's law. That is, susceptibility is proportional to 1 upon temperature. That is, they lose their magnetic behavior with the rise in temperature. Paramagnetic substances lose their magnetic behavior with the rise in temperature. While in ferromagnetic substances, the susceptibility is large value and it changes with the temperature in a complex way like this. That the susceptibility is inversely proportional to absolute temperature minus the Curie's temperature. This Tc is Curie temperature. Due to this reason only, they can be magnetized easily and strongly. As the temperature increases, the susceptibility decreases. This is known as Curie-West law, and at a particular temperature, that is known as the Curie temperature, this ferromagnetic substance changes into paramagnetic substance. Likewise, iron has Curie temperature at 1000 Kelvin. Now, the diamagnetic material, when placed in a magnetic field, the field lines will tend to avoid the substance like this. It is placed in the magnetic field line, the field lines are avoiding this substance because its function is to repel the magnetic field lines. While in paramagnetic substances, when placed in magnetic field, the field lines prefer to pass through the substance rather than through the air, as shown here. This is the magnetic field lines of the external magnetic field, and this is the paramagnetic substance which is placed in the field. The field lines are trying to move towards the substance as it is a paramagnetic material because it is weakly magnetized, and the lines of the force tend to crowd in the substance as shown here. The magnetic field lines are trying to pass through the substance. Therefore, it will be strongly magnetized in presence of the external magnetic field. So, when diamagnetic substances are placed in non-uniform magnetic field, these substances have the tendency to move from stronger to weaker magnetic fields. Like here, see, these are the poles of the magnet, north pole and south pole. As the poles are quite close to each other, the strong magnetic field is at the center, and the diamagnetic substance has the property to repel the magnetic field. So, the diamagnetic substance will be away from the center and will try to collect near the poles. And when these poles are moved far away, then the magnetic field strength at the center is much less as compared to the magnetic field strength at the poles. So, the diamagnetic substance will collect at the center and try to leave near the poles as shown here. Now, in paramagnetic substance, they have the tendency to move from weaker to stronger magnetic fields, but slowly. Again, see here in the figure, this is the north and the south pole, and they have the maximum field strength at the center, and the paramagnetic substance try to move from weaker to stronger magnetic fields. Hence, the substance will try to collect at the center where the magnetic field strength is greater and will move away from the poles where the strength is less. If we move away these poles, the strength at the poles will be greater as compared to the strength at the center. Therefore, the paramagnetic substance will try to collect at such a place where the magnetic field strength is greater, that is at the poles, and will try to leave the central part where the field strength is less. Same is the case with ferromagnetic substance. They also have the tendency to move from weaker to stronger magnetic field, but rapidly. Same is shown here, that is, they try to collect at the center where the field strength is greater, and if the poles are at far distance, they will try to collect at such a place where the magnetic field strength is high, that is near the poles, and will try to leave the central part where the field strength is less. There can be many examples of diamagnetic, paramagnetic and ferromagnetic substances. Likewise, we have given few: copper, lead, silicon, nitrogen, bismuth and water I have written. Similarly, for paramagnetic substances, aluminium, sodium, calcium, oxygen, magnesium, and for ferromagnetic substance, iron, nickel, cobalt and ferric oxide, Fe2O3. Thanks for watching. Please like, share and subscribe.